Welcome back to my channel, Chemistry Made Simple for NEET. I am Mrs. Lekshmy Subramaniam with a PhD in Chemistry. I hope you all have watched Unit 14 Biomolecules Part 1 and Part 2 Quick Revision and Biomolecule MCQs Part 1 and Part 2 which I had uploaded already. Please check the link given in the description box. In this video, we are going to discuss some more important MCQs of biomolecules, Part 3. Please do like, share and subscribe to my channel. Now, without wasting our time, let us continue with our session. The first question we have got for this session is a few formula based question. That is a compound with the formula C2H2O twice is. We had already discussed the general formula of carbohydrates in the previous session. So the choice given is A carbohydrate, B carboxylic acid, then C aldehyde and D is monosaccharide. So what would be the answer? B carboxylic acid. So the compound is acetic acid actually. The formula being CH3COOH. The general formula, even though it has CXH2OY of carbohydrates, it is not one. This is one of mistake of the general formula definition of carbohydrates. Notice it. This is a very important question and which mostly confuses students. So even though if some compounds obeys the general formula, it need not be belong to the carbohydrate category. Okay, now moving on to the next question. To identify the correct formula for the carbohydrate rhamnose. Choice A is C5H10O5, B is C6H12O5, C is C6H12O6, D is C12H22O11. Again, the correct formula for the carbohydrate rhamnose. So the answer to this question is choice B, which is C6H12O5. So what is rhamnose? It is a carbohydrate that does not satisfy the general formula CXH2OY. The formula for this is C6H12O5. Now, next question. Which of the following carbohydrates is not a sugar? A. Glucose, B. Fructose, C. Lactose, D. Cellulose. You have to identify which one of the following is not a sugar. So, answer is D. What is D? It is cellulose. You know that cellulose doesn't belong to carbohydrate. It's not a sugar. Like glucose, fructose and lactose are examples of compounds which are sweet in taste and so they are called sugars. Actually, cellulose is a non-sugar. It is tasteless. It is soluble in, insoluble in water and amorphous. So the answer is D. Now, which of the following is not a polysaccharide? We have learned about polysaccharide, which is one of the classification of carbohydrates. The choice for this question is A. Cellulose, B. Stachyose, C. Starch and D. Glycogen. Answer is B, that is stachyose. What is it? Polysaccharides? They are carbohydrates which has a very large number of monosaccharide units, that is more than 10 on hydrolysis. That is when they react with water, they yield a very large number of monosaccharide units. Stachyose with the formula C24H42O21. It's a tetrasaccharide which gives 4 monosaccharide units on hydrolysis. Okay. Next one, which of the following monosaccharides it is? It's a ketohexose. We learned the structure of aldohexose and ketohexose if you remember in our previous units. Those who haven't watched my previous units can go back to the units given before and the link is given in the description box. So the choice is A glucose, B galactose, C fructose and D mannose. The answer is C fructose. Because fructose is a monosaccharide, it consists of 6 carbon atoms, which includes a carbonyl group of a keto group. But glucose, galactose, mannose, these are all examples of aldohexoses. So from this point, if you are asked about any other compound, which is an example of aldohexose, you remember the names. These are glucose, galactose and mannose. Now, erythrulose, it's a aldotetrose, B aldoheptose, C ketotetrose, D ketoheptose. So erythrulose is actually what? It is a ketotetrose. So it is a actually erythrulose is a tetrose carbohydrate because actually it has 4 carbon atoms and its formula is C4H8O4 and it has one ketone group. So it belongs to ketose family. Okay, next one. I remember having mentioning about the preparation of glucose uh, in the small scale as well as commercial production. That is from the hydrolysis of uh, what substance when boiling with dilute H2SO4 at 393 K under pressure gives glucose A starch, B sucrose, C galactose, and D dextrose. Those who have gone through my previous units would be able to answer this question quite easily. The answer is A. What is A? It is starch. So here we'll see once again quickly how is glucose prepared commercially. So actually a cornstarch solution, it is acidified with dilute sulfuric acid and heated under a pressure of 2-3 bars, and after this hydrolysis takes place, then this liquid is neutralized with sodium carbonate and concentrated under reduced pressure. We get glucose crystal. This process is also used to get glucose from cellulose. You learn this process really well and thoroughly. Now the next one, the reaction of glucose with which of the following proves the presence of aldehydic group. So one is potassium iodide, B hydroxylamine, C bromine water, and D acetic anhydride. I repeat, the reaction of glucose with which proves the presence of an aldehyde group. The answer is option C, that is bromine water. So what happens when treatment with bromine water? The glucose gets oxidized to gluconic acid. What is gluconic acid? It's a 6-carbon carboxylic acid. It shows that the carbonyl group is present as an aldehyde group. So the answer is option C. Now, glucose on failings test gives. This is asked to confuse the children. For most of the exams, part A, no reaction, option B, silver medal, C, red precipitate, and D, pungent gas. So the option is red precipitate. Glucose on failings test gives a red precipitate because glucose is readily oxidized. It's a very strong reducing agent and it reduces failings reagent to give a carboxylate compound, that is in the place of CH2, CHO group, which is oxidized, and also along with this you get a red precipitate of Cu2O or cuprous oxide. And the next one, the reaction of glucose with hydrogen cyanide confirms. First choice is straight chain structure of glucose. B, presence of a carbonyl group in glucose. C, presence of an aldehyde group in glucose. D, presence of keto group in glucose. So if it is a straight chain or presence of carbonyl group, aldehyde or keto. So what happens when glucose reacts with hydrogen cyanide? So the option is presence of a carbonyl group in glucose, which is B. That is when hydrogen cyanide and glucose reacts, they form glucocyanohydrin, and the carbonyl double bond is cleaved to form one COH bond and one CCN bond, showing the presence of a carbonyl group. Hope it is clear for you. And all these questions are mentioned in the unit biomolecules of class 12. You can go through my unit 1 and 2 for quick revision, so that you will have an easy understanding of the topic, and you'll be able to cover more questions. That is why I'm not going into each of the lesson in detail, because if you learn by this method you can finish more number of questions, and since you are doing a quick revision of the topics, I've included all the important topics given in the textbook of class 12 NCERT Biomolecules, and from each of the topic I've included questions which have come for the exams for previous years as well. And the next question is, which of the following tests does glucose give? A, tolerance test, B, 2,4-DNP test, C, Schiff's test, and D, addition product with NaHSO3 sodium bisulfate? So answer is choice A, tolerance test. Because glucose has a CHO group, still it does not react with sodium bisulfate because it doesn't to form an addition product, and it or give either Schiff's test or 2,4-DNP test like other aldehydes, but it forms a silver mirror on treatment with Tollens reagent. See, we have got so many important points in this particular explanation. What are tests glucose give and what test it does not give. So these observations show that existence of glucose in other forms, and it gives way to the cyclic structure of glucose. The next one is the hydroxyl group at which carbon is involved in the ring formation in glucose. If you carefully had watched my previous session revision, you'll be able to answer this. A C3, B C4, C C5 and D C6. The answer is C, option C, C5. In glucose, the six-membered ring, which is known as the hemiacetal structure, is formed between CHO group and OH group of the C5 carbon. Now, which form of glucose is obtained by crystallization from hot and saturated aqueous solution at 371 K? If it is D form, L form, alpha form, or beta form. So the answer is D form. So D form is the form of glucose obtained by crystallization from hot and saturated aqueous solution at 371 K. So when you heat a saturated solution to about 100 degrees Celsius and crystallize it, the beta form of glucose is obtained. On the other hand, a concentrated solution at room temperature, that is without heating, if you crystallize it, it gives alpha form. So now you understand the difference on how you get alpha form and beta form. Now, when alpha form of glucose is dissolved in water, then it is allowed to rest. What will be the percentage of beta form in this solution after some time? So, how much percentage of beta form you will get when you dissolve alpha form in water and allowed to rest? A 0, B 36, C 64, D 100. So, the answer is C 64. If you dissolve either alpha or beta form of glucose in water, it is allowed to stand. An equilibrium mixture of both the forms are formed, that is 36% of alpha and 64% beta form. Because of the spontaneous change in the specific rotation of an optically active compound with time to an equilibrium value, this phenomena is called muta-rotation. So I've included in the explanation definition for the phenomena of muta-rotation as well, and what percentage of alpha beta forms you can see in this. Now, next question. When the OH group at anomeric carbon lies on the same side as that of the OH group on C3 carbon, what is it called? So, for an anomeric carbon, if the OH group lies on the same side as OH on C3 carbon atom, OH group at anomeric carbon lies on the same side as that of OH group on C3. It is known as A, alpha glucose, B, beta glucose, C, D glucose, D plus glucose. So the answer is B, beta glucose. That is the OH at C3 carbon. It always lies on opposite side to that of OH at C2 and C4 carbon in all glucose structure. So remember this point. So the sides are opposite. OH at C3 is opposite to that of OH at C2 and C4. So when the OH of anomeric carbon lies on the same side as C2 and C4 carbon, then carbon OH group, then it is known as alpha form. Otherwise, we call it beta form. You can see that in the structure of glucose, which we had already revised in the previous unit. So now we have come to a close of this session, and I hope you understood all the points very much clearly, and you remember one thing: when you're losing motivation, just remember how amazing you will look in the white coat. Imagine yourself graduating from your medical college. Imagine yourself in a white coat with a stethoscope around your neck. Imagine saving someone's life. What a beautiful thing that would be. And with that thought of the day, we are coming to an end of today's session. Hope you all liked my video and found it useful. I'll come back again soon with another amazing session. Till then, you keep on revising all these sessions and the MCQs well. Thanks for watching.